Okay. Now we are live, ladies and gentlemen. Couple of things before we move forward. Number one, just so, and I may have said this in the past, but obviously I just want to say it again. You have Monday off. So that means that the next time I will see you is on Tuesday. Next week I will see you on Tuesday, Thursday again, just to make sure you have your schedule correct for that. Grades have been submitted. If you have any questions in regards to that, please make sure you are messaging me because I want to make sure that things are taken care of in a quick fashion, because I know that obviously we're going to be at the end of the school year before you know it. You think about it, like we're already like halfway through April. Like it's insane to think about it. Literally in 2 months we'll be done with the school year. Just I don't know. And speaking of which, there's going to be a brand new system being put into place on April 26th. Yeah, actually, last class period, they were actually setting up picnic tables in the courtyard. You know? It could be. Oh. I'm not really sure on the details. We're talking about she was talking about getting used to like the schedule that we have, and they're changing it up again. Just getting used to. You've been doing this for well, there are a lot of people who haven't gotten used to it yet, and people who have been alternating between virtual and in school and vice versa. Yeah. I agree with you. So, but anyway, regardless, all right, regardless, we are gearing up. Hold on, we are gearing up for the end of the school year. Hold. Shh. Guys, I'm still talking. No, they're still talking quietly. I said we are gearing up for the end of the school year, so you need to be aware of that, and you need to be on top of things because it's going to sneak up on you before you know it. Now, in regards to this chapter and what I want to do today, I do have a worksheet that I want to basically work through in order to practice some of the skills that we've been doing for the past several class periods. In the past 2 or 3 class periods, we have been working with factoring, of course, but we've been working towards simplifying, multiplying, and dividing these rational functions, and adding and subtracting these rational functions is something that I just started introducing last class period. What I'm going to do in a moment, and this is for all of you online as well, because I see 2 people online for some reason. That's weird. But for all of you online as well, I am going to be posting a PDF worksheet to the Google Classroom. So you will need the Chromebook out in order to access it. The reason why I did that is so that you could zoom in on the individual problem, because some of the problems on it's a pre-made worksheet for the chapter, and some of the problems are kind of smallish. So I figured, well, if I give it to you in PDF form on the computer, you at the very least can zoom in and decipher what it looks like. So please, if you would, I'm going to be posting this to the Google Classroom stream in a moment. If you would access that to make sure that you can open this PDF for today, post. Boom, it has been posted. So your first task today is to make sure that you can open up this PDF. Going to flip it over to this screen right here. Come on, thing, load. There it is. Good. Now, it says mid-chapter test at the top, but this is not a test. This is not an assessment. This is a practice, and I liked these problems for what I wanted to do today, which was to practice some of this information. Now, clearly, obviously, even on the work, like I have this thing blown up on the screen, but you can still see some of these things are rather small, which is why I wanted it on the computer, so you had the ability to zoom in on some of these problems. Some of these problems I'm going to give you an opportunity to try on your own. Some of these problems I am going to walk you through with a few hints along the way. I'm going to skip around. I'm not going to hit number 1 right away. I'm going to come back to number 1. In fact, the first 2 problems that I'm going to start with are numbers 2 and 3. So yes, you have your Chromebooks open, but I am also going to ask that if you do not already have them out, I'm going to need your notebooks also out and open. I would like you to put these problems directly into your notebooks so that you have the examples. Let's see if I can zoom in on this thing right here. There we go. Like I said, even though they're rather zoomed in, it's still somewhat difficult to see some of these problems. So this is going to be, I'll show you the title in a moment, but this is going to be Rational Practice. Today is April 15th. I hope you have submitted your taxes. No, today is tax day. Well, if you have a job, you earn money that you pay taxes on. Hey, what? Well, not all of it back. Yeah, some of it maybe. You know, it depends. See? Wasn't that pretty solid? Yeah. Today is the deadline. Well, getting paid under the table is a different story. Well, if you're on, all right. So anyway, back to this. The example that I'm going to start with is obviously number 2. And I want you to notice something about number 2. I want you to notice something about number 2. First of all, when I wrote it down, I left that top right portion blank. I did that on purpose. I left that top right portion blank because I'm not going to copy it down exactly as the problem shows me. The reason being is because of an example that I showed you last class. Last class, I showed you this problem. I showed you that problem. We wrote that problem into our notes. And I showed you that problem for this very specific instance. They will try to mess you up with problems like this. You can't just cancel them out because they don't match each other exactly. You're going to have to finagle part of the problem. And what I did here the other day was I changed this 6 minus x to be a negative x plus 6, and then I factored out a negative 1, forcing the problem to look like this. We're going to be doing something very similar here, where I'm going to switch around the 1 minus 2y to make it negative 2y plus 1, but then I am also going to factor out a negative 1. So it should look like this. It should look like that. Now, in a few minutes, I'm going to have you actually finish this problem for me, but I want to show you some extra stuff on number 3 before I do that. Keep in mind, when you begin working on this particular problem, you are going to be factoring the top left portion of this fraction. You are going to be factoring using whatever quadratic factoring method you have. I used the Tucker method. I taught the Tucker method. I've reviewed the Tucker method. But if you prefer a different method that works, make sure you can show the work on it. But that needs to be factored before you begin canceling stuff out. Then, on number 3, which you guys are going to be doing that one in a minute, but you're also going to be doing number 3, Let me flip back to number 3 real quick. Example for number 3. What is the big difference between number 3 and all the other problems that we've done up to this point? What is the big difference between number 3? Yeah. What the heck? Dividing fractions? Dividing fractions? I don't like that. Notice what I've written so far. Notice what I've written so far for number 3. Pretty much next to nothing so far. There's a reason for that. I have not taught you this. I think you learned this back in 5th or 6th grade. What the heck are you supposed to do when you divide fractions? Say it one more time. Which part do you flip? The second fraction. The second fraction, yes. The second fraction will flip. You will find the reciprocal of that second fraction. And when you find the reciprocal of that second fraction, you can change it. Remind me one more time, you can change that symbol to what? Multiplication. I believe the phrase that some of you may have been taught in the past was keep, change, flip. Which means you keep the first fraction the way that it is. Can't see it. There it is. You keep the first fraction the way that it is. You change the sign to multiplication. And you flip the fraction so it will look like this. Then you can proceed as normal. So here's what I want you to do. I want you to practice these 2 problems. I'm going to give you a small block of time to get both of them done. I've explained what needs to be done on the first problem so far, that changing of the numerator to make it look like the denominator on the other side. You are going to have to factor this top left. On the second problem, you're going to have to factor all 4 of these. All 4 of these can be factored. You tell me, before I set you off, which part of this problem requires a GCF? Which part of number 3 requires a GCF? You could say like top left, top right, bottom left, bottom right. I hear crickets. Only one of them does. Because the GCF on the other ones are all 1. This one? This one? Well, I haven't confirmed or denied any of your guesses. Why? You could take a 3 out of it, yes. Yes. On this one right here, you could take a 3 out of both of them. And that's what you should do to start the problem. Take the next 5 or so minutes, maybe less. I want you to knock out both of these problems. Give it a shot.
which questions are we on?
These two. Numbers 2 and 3 off that worksheet.
So bad. I just don't understand. I don't know why. I can understand everything else. Factoring, I'm just like dumb. It's true. Give me any equation, I probably wouldn't be able to factor it. I'm like, oh, I can solve it, but I can't factor it.
Oh. It's always a good idea to walk yourself through the steps, or possibly, if you're having trouble remembering steps, let's say the Tucker method.
It's like, I don't even know where to, like, once I get in the groove of it, I'm able to, like, figure it out, but I don't even know where to start.
Well, one suggestion for kind of getting used to the steps, and you said getting into the groove, but what about at the beginning? How do I remind myself of this? Sometimes what I try to do.
Rules, like, you can do it in this circumstance, but this is fine, you have to do this.
No. I have a simplified version of the rules. I know that each of the rules have a lot of nuance to them, okay? But if I'm trying to remember it, sometimes I'll write out the rules next to the problem for myself as a reminder, and then I'll work myself through the rules if needed. Now, keep in mind, factoring, the Tucker method way, let's say factoring, can really only be done to this part of the problem, this part, and this part. Because it applies to quadratics. I always try to remember the first step is always GCF, which is like the step that most people kind of skip over, but it's the letters that they recognize the easiest. Step 2 is just A times C. Within the problem, it's the A coefficient multiplied by the C coefficient. Now, step 3 has a lot of nuance to it. When I'm trying to remind myself of step 3, I just try to remember the phrase magic numbers. Because it's two numbers that have to multiply to AC, and it has to add up to the beat down. But when I'm writing down my steps, I'll just write magic numbers just as a reminder. Step 4, again, a lot of nuance, but I only write down sheet chart / simplify. Because that's when I have to organize the information into the T-chart and simplify it if I can. Because if I can simplify it, I should simplify it. Step 5 is kind of a nonsense step. But it's basically where you finally write the factors for the problem. This is like the bare bones list that I would write for myself if I was practicing these problems. Like, if you go back to the quadratic equation, you know, the whole negative b plus or minus, blah, 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 blah. When I was first learning that, what I would do for myself, nobody told me to do this, I did this for myself. I would write the equation out every time I used it.
Yeah, that's what I do.
So every time I use the Tucker method,
I like to
factor.
remind myself of what I'm supposed to do.
Exactly. And this is the reminder that I would write for myself here. I'm just, again, me personally. It may not work for everybody, but it's what I try to do to kind of like, okay, what do I have to do first? Oh, just go through the steps. And that's why I try to remind you guys about the GCF. This is the only one that uses the GCF. Because all the other GCFs are one. Well, technically, that was a GCF as well, but I did that step with you guys.
So the GCF is just one for the top one.
For most of them, it's all one. Obviously, this one was like a special case. But this is the only one where you take out a GCF that's not one.
So like even though like so like see like the bottom right one on the first equation. Yeah, so since the one is a negative.
Well, technically, it would be just positive. Just like technically the GCF is positive 1 here. It still technically is just positive 1 because it's the only thing that I can divide by both terms. What I did up here was a special case of manipulation because I needed it to look like that. But a direct consequence
So
was.
wouldn't that just make it a negative 2 once you distribute it?
Once I distribute it, but yeah, this is what it was originally. Look at number 2 on the worksheet.
Yeah.
That's what it was originally. So then and like you just said, yes, it is a negative 2y. But then I forced out a negative 1 as a GCF to make it look like this. Now, yes, if I distributed it back in, I would be going back where I started.
Wasn't that eventually you want to do?
Not for this one. Oh, goodness gracious. The reason why I don't is because I wanted this to cancel out with this. And the only way that that happens,
Just left the negative 1 on the bottom.
exactly. The only way that that happens is if they look like each other exactly.
But you can't like do that with the top left and the bottom right because there's an exponent on the top left, right?
And a 9. And that's
So
a 3.
With the GCF, would you make that equal to GCF?
So what you're going to have to do is you're going to have to factor this. And when you factor this, I'm telling you because I know what the problem looks like. One of those 2 factors are going to cancel out with this one. I'm going to go over it with you guys. No worries.
Yeah, because I don't know why. Like this is like the simplest thing I feel, but it's I don't know. There's just so much to it.
There's like, well, I know I've used this word a lot today, but there is a lot of nuance. And nuance is like the tiny little details that no one really thinks about, but it heavily impacts the problem. So let's see where this actually takes us. There we go. Okay. Now, if I'm doing this problem, I set up a lot for you already. Number 1, I set up the 2y minus 1 up here. Notice what is separating this 2y minus 1 from everything else in the problem. What operations? And that's it. But because it's just multiplication and division, the 2y minus 1s cancel each other out. And Declan, as you said before, that negative 1 is still there. We'll deal with that negative 1 later. The top left and the bottom right do not cancel each other out. I am going to have to factor the top left of that problem. And I'm going to do it using, as we've talked about, the Tucker method. There's no GCF to take out. But if I did A times C, I would get -9. First term times the last term. If you notice, the middle term is not there. There's no B term in the middle. On the next problem, we'll have B terms. But on this one, we have nothing in the middle. So the B value is 0. And since the B value is 0, someone get that? I'm looking for these two magic numbers. What's up?
Hey, is Christopher here? Can I speak with you, please?
I have no idea. Do you know what this is about?
Couldn't tell you.
All right. All right, cool. Once I have those two magic numbers, and again, I'm working my way down the teacher, or down the, whatchamacallit. I think this is awkward when somebody calls a student out into the hallway and then we all want to like listen to the conversation. You know what I'm saying? No, that's why I'm actually talking right now, to distract you from that conversation, to kind of give him a little bit of the privacy that he kind of deserves, because you guys shouldn't be eavesdropping on his conversation. You know, well, just because it's rude and it's not fair to him.
So are you gonna go to the time update tonight?
No, unfortunately, no. I'm sorry. The rest. Now, here's the thing. I'm vaccinated.
Yes.
I'm fully vaccinated, but my family is not, and my wife and my kids are currently quarantining because we went out of state during spring break.
No good.
I know, but since I've been vaccinated, the guidelines from the CDC and the State Department of Health say that since I'm fully vaccinated, I don't have to quarantine for those 2 weeks. You know what I'm saying? But my family does. So it'd basically be like, my wife is home right now with my 2 kids, my 7-year-old who's doing school online. And then I'm basically, okay, wife, I'm home for like a couple hours, and then I'm going to leave you here so that I can go out and do something fun. Yeah, you know,
Very nice of you to be caring enough to do that.
it happens. So anyway, back to this. I put my magic numbers in the bottom. Now, in the top, I got to split up that 9y squared. But I don't know exactly how to split up that 9y squared. Do I split it up as 9y and y? Do I split it up as 3y and 3y? You don't have to worry. Make them both a 9y. And when we simplify, that t-chart will take care of itself. Now, you were talking about, you know, the Tucker method, like that. We're going to be going over the steps over and over and over and over and over again. But again, I'm just doing this 5 steps, always for the Tucker method. When I simplify, 9 over 3 becomes a 3 over 1. 9 over -3 becomes a 3 over -1. And I get the factors 3y plus 1. That's vertically right here, 3y plus 1. And 3y minus 1 vertically right here. It's a weird problem, I know. And I'm writing this out the long way. I'm writing this out the long way so that you can see each step in its glory. But now watch what happens to this problem. This problem ends up looking like this. Now, I am going to cross that out again like I did before, just so you can see what happened to them. There we go. That's what this problem turns into. Now, what do you notice about the top left and the bottom right? Say again? Which cancels? Yes, that cancels. The other one does not. Everything has canceled that needs to be canceled. We can either leave our answer like this, which is perfectly acceptable, or we can distribute that -1, and that would also be an acceptable answer. Either one would be acceptable. But that's what we got. -1 times 3y plus 1. That's the simplified version. Now we're going to do that again on the next problem. I'm just going to take a little bit of a shortcut along the way. So I don't have to do all of these extra steps up here. I'm going to try and condense a lot of the work with the next problem. But let's see what we got. With this next problem, I am going to have to factor a number of times. Actually, all 4 times to be specific. Remember before we changed the division to a multiplication and we flipped the second fraction. That's what you learned back in the day, where you keep, change, flip in order to get that answer. Now I'm going to draw out these 2 fractions. Here's the first thing that I would work on. The first thing that I would work on is the top right. I work on that top right because, well, I can take out a greatest common factor of 3. The first step in the Tucker method, GCF. But I don't have a quadratic, so the top right of this problem is done. The top right is, that is. I'm going to leave that there temporarily because that's all that I can do to the top right side of that problem. Now let's look at the top left. Now I'm going to walk up to the board for this one because I'm going to draw something and then I'm going to erase it afterwards. Now, check this out. Yes, technically, we're going to have to walk through the Tucker method here. But I'm going to save you some energy here. What is my A value on this problem? Not the variable c squared, the coefficient on c squared. 1. The A value is 1. When the A value is 1, this is the nuance, part of the nuance I was talking about. When the A value is 1, this part of the Tucker method is actually not necessary. When the A value is 1, you don't actually have to draw out the t-chart. I'll show you why in one moment. If I'm going to do A times C, I get -20. Because, well, 1 times -20. And then I got to find 2 magic numbers that multiply to -20. What do they have to add up to? -1, because, yep, that's a -1 right there in the middle. So that's got to be what, -5 and 4? Yeah, that works, right? Well, yeah, they multiply to -20 and they add up to +1, right? I'm sorry, -1, which is what you told me they had to add up to. Yes. So those numbers work. Now, this is why the t-chart is not needed for this problem. What's going to go in the top of this t-chart? A 1 what? Yes. Does anything simplify? No. When that first term is a 1, nothing will ever simplify here. So in reality, you don't actually have to go through this process. It's a C minus 5 and a C plus 4. But watch what happens now. I said I would write this on the board and then erase it, right? I'm going to erase this junk. When your when your A value is a +1, you can simply ask yourself the following question. Can you give me 2 numbers that multiply to -20 and add up to -1? -5 and 4, right? The squeakiness makes me feel alive. Now look at the bottom left. You see how the A value is 1 again? It's a 1c squared. Can you tell me two numbers that multiply to positive 5 and at the exact same moment add up to negative 6? They have to multiply to a positive, but they have to add up to a negative. Give me any two numbers that multiply to 5. Multiply to 5. 5 and 1, but they add up to positive 6. Negative 5. Negative 1. Yeah. You could do the same thing down here. Isn't this a 1c squared? Can you tell me two numbers that multiply to negative 16, but then add up to, I guess, 0? Because that b value is missing. 4 and negative 4. Now that everything has factored, now that everything has completely been factored, tell me, does anything cancel out? What? Name it one at a time. The C plus 4s, the C minus 1s, the C minus 5s, done. That's what you're left with. See, for this problem, you don't actually need to write out the Tucker method because the leading term is a 1. Yes. Oh, let me look at the answer choices. Yes. Yeah, it's A. You notice how they're all like very similar to each other? Yeah, they're all very similar. I know.
And then I make a mistake and then I see that it was wrong. And I was like, oh my God, I'm so dumb.
Well, look at this. Look at this. Look at this real quick. You see how we had the answer for number 2 right there? Remember how I said you could write the answer like that or you could distribute it? If you distributed it, the answer would look like that. If you distributed the negative 1. Now look at the choices. Look at the choices for number 2. It's the first one. It's the first one. I know.
They're so foul.
They are. You want to see something even more foul? We're going to do number 4 together. Oh, yeah. We're going to do number 4 together. Take a look at number 4. Shed a tear onto your desk. That is required that you shed a tear onto your desk. And then we're going to write something down. Is your desk properly tear filled? Check this out. On number 4, let me move it up a little bit for those in the live chat. There we go, so they can see it a little bit better. On a problem like number 4, there is a heck of a lot of division signs going on here. But is there one that is unlike the other? Which one? No. Division signs. The middle one. The middle one is unlike the others. Because, ladies and gentlemen, the problem is really telling you to take this fraction right here and divide it by this fraction right here. Because of that large division symbol in the middle, that is what they're actually telling you to do. Now, how we write that down on paper, I'm going to start writing it out, and then I'm going to flip my camera over so you can see it. Let me start writing it out, and then I will show you what it is they're actually asking you to do. All right, here we go. I wrote out what the problem is asking you to do. That's what the problem says currently. Let me flip my camera. This is what they really want you to write. This is what they want you to write down when beginning to simplify this problem. Let me get rid of those parentheses so I can flip back and forth and the parentheses not mess you up. But that's what I want you to write down. We're gonna finish out this problem kind of together. That's what it is. That's what they want you to write down. The large division symbol in the middle, the large division symbol in the middle of this problem, the thicker one, is represented by this division symbol right here. That's what they want you to write it as. Now, I'm going to go through a little bit of a process. Let's take care of this one section at a time. First and foremost, is there a GCF I can take out? What is it? Can I what? Can you divide both terms by the same thing? Doesn't matter if it's negative. What can you divide? 3. So we'll do now we're not done with the top left. We are not done with the top left. We're not. But we'll finish it in the next step. Is there a GCF we can take out of the bottom left? Yes, because they both have an M in common, and they both have a 4 in common. So I can take out a 4M, and we're left with M plus 2. Now, temporarily, I'm going to leave the division symbol as is. But in the next step, I'm going to have to change it. What can you take out of here? 6 parentheses M minus 2. What can I take out of here? 8M. Parentheses M plus 2. Now, I'm nowhere near done. But all that we've done, literally, all that we've done as the first step in all 4 sections is GCF. That's all that we've done. Greatest common factor. Now, in the next step, I'm going to have to take care of a little bit more. Here, let me show you what you missed so far. Ready? You see this problem, number 4? You see the division sign in the middle that's a bit larger? Yeah. Okay. In reality, because of that division symbol in the middle, this is what they really want you to think. Now, I'm going to flip it back and forth real quick just so you can see this. But this division symbol is the same thing as that thicker division symbol. The bottom fraction, 6m minus 12 over 8m squared, blah, blah, blah. That's that right there. For the first step that we did, the only thing that we cared about with the first step was greatest common factor. That's the only thing we cared about. And this is what we did so far. Greatest common factor out of all 4 sections. Now, I can factor this junk. I got a quadratic here. This is nothing more than the side note. Remember we did a side note a couple, was it last class or the class before?
I don't think it was last. I think it was the one before.
But you remember I wrote like side note and wrote it down the side? Literally, that's what it was, just with a different variable. That's what it was. So in reality, I'm going to make this a 3 parentheses M minus 2, M plus 2. Because there are 2 numbers that multiply to -4 and add up to 0. I'm going to keep the bottom left the same. But now I got to change some stuff. Keep, change, flip. I had to be very careful when that keep, change, flip took place. Yeah, probably. I could have done that keep, change, flip at the very beginning, but I chose to do it there. Then you ask yourself the question, does anything cancel? The answer is yes, of course it does. Watch this. The m plus 2's. Let me ask you a question. Very important question. Unbelievably important question that several people end up messing up every time. Do you agree that these m plus 2's cancel? What about that m plus 2? Why not? There's not another one. That's the key, though. There's not another one to cancel it out. Some people think, oh, but there was an m plus 2 on the bottom. No, sorry. This one canceled out with this one. They cancel out 1 for 1. There has to be an additional m plus 2 for that to cancel out. So that m plus 2 stays put. But these m minus 2's cancel. Good for them. Hey, look what the heck happens here. You see this 3 times 8? And you see this 4 times 6? What does that end up being? I got a 3 times 8 on top. I got a 4 times 6 on bottom. Come on, basic arithmetic. What's on top and what's on bottom? Yeah, because remember, it's multiplication now because I changed it. Keep, change, flip. 24m over 24m. Nope, there's something left. There's still an additional m plus 2 sitting there. Nice. Now, yeah, let me look at the answers real quick. Boop. So they had F, G, H, J.
They try and trick you with all the ones that look more complicated. You're like, it has to be one of those.
I know. But yeah, it was H. It's definitely that H right there. But you have to justify it. This is the justification behind it. This is the justification behind it. Let's look at a few more here now. Let me zoom back out on this worksheet. Let's see. Let's do number 5. Yeah, we'll do number 5, and then if we have time, I'll do number 6, but I want to focus on number 5. The first thing that you should always focus on when doing problems like this is factoring. However, for number 5, no factoring actually needs to take place. For number 5, you got 1 over 5 minus 3 over 4w plus 3 over 10w. Oh, snap. I have to combine all 3 of those? Ugh, that's disgusting. I need a least common denominator. Least common denominator? Oh, goodness. Is there a number? Ignore the variables for a moment. Ignore the variables for just one moment. Is there a number that you can get the denominators to become that would be common amongst all 3? Yeah, 20. 5 and 4 and 10 could all be turned into 20. 2 of them have a W. This one's missing that W.
Whatever you multiply by has to be like 10w would be like 2. Right? What?
I would multiply by 2.
So for the 5, it would be 4w.
You find out what that common denominator could be, and in this case, the common denominator should be 20w. And since it's 20w, watch what I'm about to do here. Actually, you know what? I'll do it right here on the side. Here we go. I'll just write it next to each of them. I'm going to multiply that first fraction by 4w. Let me zoom in on that. I'm going to multiply that first fraction by 4w to make it 20w. What do I multiply the second fraction by? Just 5 over 5. Yeah, because it already has the w. the basic question is, well, what is it missing in order to get to that common denominator? What do I multiply the last one by? Yeah, just 2 over 2. Go for it.
How can you multiply 1 over 5 by 4W? Like, how can you add a W?
Technically, I want you to...
I was thinking on that at first too, but I realized it's like all of them have to be the same.
Mhm.
Then, like, how to make a common denominator?
What's the common denominator for what I wrote in red? Oh, sorry. I'll write it higher. Hold on. No, that's not the common denominator. The least common denominator is 6. There's a difference between least common denominator and greatest common factor. 6, though. Would you agree? What did I just multiply that fraction by? Technically 1. Meaning, I am changing the way it looks, but I am not changing the value. I am changing the way it looks, but I am not changing the value. That's a huge, huge thing right there, because now I get 4 over 6 plus 3 over 6, and I can add them together to get 7 over 6. Even though it doesn't originally have it, ultimately, I'm going to get a 4W over 20W. But this is the exact same thing as the fraction 1 over 5. They are the exact same value. They just look different. If I throw in that W over W, it seems like I'm cheating a little bit. It seems like, well, you're just throwing in variables where you need them. Well, the reason why I'm allowed to is because of what you kind of said before. Technically, what am I multiplying by? Well, what's 4W over 4W? That's true. But I'm saying that you just said I'm multiplying by 1, right? What happens to anything when I multiply it by 1? Stays the same.
I know, and I get that, but I still, because like, wouldn't W have a value?
Technically, it's an unknown value.
Exactly. So then we don't know what it is. We're just being ignorant and using it to our advantage.
Kind of. But in one sense, it's like this. Remember how I multiplied that previous fraction by 2 over 2? A variable is just temporarily taking the place of a variable. That's all that it's really doing. When I multiply this fraction by 2 over 2, it is no different if I multiplied it by x over x. There's no difference between them. It's just that x is standing in for the 2. Up here, I'm going to get 4 over 6. Down here, I'd get 2x over 3x. But technically, it's the same concept. It's the exact same ideal. It's the same method. It's just that instead of using a number, I'm just simply using a variable. The variable is just some unknown number yet to be named. Like, name a number that's not 2. 8. Now the variable has been replaced with 8. And I've made this 16 over 24. It's just a placeholder for any number, or insert number here. Yeah. It kind of feels like you're cheating it, right? I know.
Math doesn't make any sense to me.
It makes dollars.
It doesn't seem right, but apparently it is.
Well, it's not so much that apparently it is. There's 2 ways of looking at math. Now, I'm going to still finish this problem because I still have time, which was my plan. But there's 2 ways of thinking about math. In one sense, mathematics is flawed based on the way that human beings describe it and the type of symbols that we use to write it. Mathematics is flawed because of the way that human beings do it. Well, hold on. I'll explain that in a moment. The other way of looking at math is the abstract sense of just math is perfection. Because even if human beings were not here to describe math, math would still be a thing. Now, I see what you're saying. Why can't he's just basically saying, why can't you just add two things together and let it be what it is? If we didn't have a concept of variables, we would not have the advanced society that we live in today. That's a fact. It's a fact. If it were not for the advancements in mathematics, you would not have any of the luxuries you would have today. None of them. No, it's not all made up. The way that human beings decide to describe math is made up because it's a language. But I'm saying that there's two ways to look at math. One way is the way that human beings describe it, which is flawed. The other way of looking at it, is the fact that mathematics exists even if human beings don't. Not so much, because we can prove that things have been done correctly.
Then how do we know it's right? It might make sense and we can prove it in our own way, in our own human understanding, the way to prove it.
Mm-hmm.
That could be wrong.
Well, just because we don't fully understand something, just because we don't fully understand something, should that stop all progress?
Yes. Because we could be doing it wrong, and then it could create further damage.
Well, talk to any scientist. Ladies and gentlemen, I still have a minute left and I'm still working. I don't know why people are packing up when I haven't finished the problem. No, those were fantastic questions, though. Don't get me wrong. They were fantastic questions. And honestly, that conversation, I could have a conversation with someone about that for hours on end. Believe me, I could. And believe me, I know I'm right. But finishing up this problem, though. Ultimately, when you add everything up, the denominator is going to stay the same at 20W. And I'm going to combine like terms. 4W minus 15 plus 6 ends up being 4W minus 9. That is the simplified version of this problem. I am going to be assigning you something to practice this stuff over the course of the weekend on Google Classroom. Give me one moment because the bell's going to ring. I will be assigning you something. Pay attention to Google Classroom. If you haven't left a comment in the chat, please make sure you do so. I will see you on Tuesday. Go with your question. Go ahead.
Can you not do something with the 4W and the 20W?
No. For the simple reason, or not the simple reason.
Is it because the subtraction sign?
Yes.
Oh, okay.
Yes.
Oh, because it's separated by the subtraction, so you can't. Okay.
Exactly.
See, I remember I've taken some parts. I remember some parts.
But that's the main, because remember, we first did multiplication division, where you could only simplify if it was only multiplication division separating. And now I'm doing addition and subtraction, but those previous rules still apply.
Yeah, okay.
Yep.
I understand.
No worries.
Have a good day.
You too.